In this video, I'm going to be working free response question 5 from the 2024 Calculus BC exam. And it looks like they're giving us a table of values for the derivative of a function, and f is twice differentiable for all x, and f of 0 equals 0. Okay, we're going to say h is the integral from 0 to x of the square root of 1 plus f prime of t squared dt. Hopefully that's familiar. Find the value of h prime of pi, again with the second fundamental theorem. We're going to do that a couple of times in number 4, but, it's very important. So some people call that the first fundamental theorem. I'm going to say h prime of x, I'm going to replace t with x everywhere I see it in the integrand, so that's the square root of 1 plus f prime of x squared. Okay, hopefully that integral just reminds you of something. You feel like you know what that actually is representing, what they're going to get at. They got to be getting at here. But for now, I'm just asking us to find the value of h prime of pi. So h prime of pi is going to equal the square root of 1 plus f prime of pi. They told us was 6. I'm going to square that, put it inside a square root. This is just an expression of numbers. I'm going to be, plenty fine with that. So that's going to be part A. Let's move on. In part B, what information does this integral provide about the graph of f, the integral from 0 to pi of 1 plus f prime of x squared dx? Okay, that is the arc length. So this is going to be the length of the graph of f on the closed interval 0 to pi. Okay, that's all they asked. What information? All right, there's the information they gave. All right, so I'm going to keep going. All right, use Euler's method starting at x equals 0 with 2 steps of equal size. Nice. Okay, I'm glad to see that on free response. To approximate f of 2 pi, show the computations that lead to your answer. Okay, what I like to do with Euler's method is kind of like set up my interval. So I'm going from 0 to 2 pi, 2 steps of equal length. You're not trying to make this hard, at least with the setup. And then I'm going to say, all right, well, I'm going to need 2 tangent lines. And that's why they told me f of 0 equals 0. So tangent line number 1. Okay, my point is going to be 0 and 0 because f of 0 equals 0. My slope is going to involve f prime of 0 equals 5. And so my equation will be y minus 0 equals 5 times x minus 0. So y equals 5x. And then my approximation going from my first step from 0 to pi is going to be, y equals 5 times x, which is now pi. Okay, so that's going to be 5 pi, and my new point is going to be x equals pi, y equals 5 pi. Okay, now I'm ready for tangent line 2. My second step. And if you're sitting there thinking dude, there's a formula for this, I know. I actually probably know the formula, but in my opinion, students in my class, I've always told them to just do 2 tangent lines. First step of Euler's method is a tangent line. Second step of Euler's method, also a tangent line. There's so much stuff you have to memorize for Cal BC that I just don't think that this formula is worth it. So I'm going to say my point here is pi and 5 pi. My slope is going to be, okay, I go back to f prime of pi equals 6. So my equation is going to be y minus 5 pi equals 6 times x minus 1 pi. Okay. And then for the approximation, because that's really what they wanted, right? To approximate f of 2 pi, yeah. So I'm going to say y equals 5 pi plus 6 times x minus 1 pi. So my approximation would be f of 2 pi is approximately equal to whatever I would get when I plugged in 2 pi for x. So 2 pi minus 1 pi, and I'm just going to stop there. You know, we could say that's 5 pi plus 6 pi equals 11 pi, and that would be great. But I don't have to do that, so I'm not going to, and I'm just going to stop there. Okay, part D seems to have nothing to do with anything. They're just going to pull out this integral and be like, here it is, do it. I am not familiar, I've not seen anything like this, really, I can't think of anything recently in AP Calculus where we've seen something so detached from the rest of the problem, but we can definitely do this. We see that t plus 5 times the cosine of t divided by 4. It's like, this is not going to be used substitution. This one is going to be integration by parts. So I'm going to say, all right, ilate. I really hope, I hope my students wrote that, because I learned one time when I was grading a UDV question that I am in the, like, major minority, like, pretty much nobody uses ilate. I happened to learn ilate when I learned calculus first time, and I didn't ever hear anything else, so I just always assumed everyone did ilate, and a lot of people do lipet or liate or something. But anyway, I've got this t plus 5, which is algebraic, and the cosine, which is trigonometric. So algebraic before trigonometric, I need to use u equals t plus 5. And then dv is going to be equal to cosine of t divided by 4 dt. And take the derivative of u, the antiderivative of dv, so that would be 4 sine of t divided by 4. Okay, remember that the integral of u dv, this isn't even a definite integral, it's just an antiderivative, equals u times v minus the integral of v du. Like this, if we were going to do, I thought we were going to have to do something with the table. Like f prime of t, cosine of t over 4 would have been fun, or something like that, from 0 to pi, or I don't know. Who knows? Or 0 to 2 pi. I'm not really sure what this has to do with the rest of the question. So, in this case, that's going to equal u v minus the antiderivative of v du. Okay, so t plus 5 times 4 sine of t over 4 minus, okay, an antiderivative for 4 sine of t over 4. Okay, last time I had to multiply by 4 to deal with the division by 4 on the inside for the chain rule. So it's going to happen again. There's going to be a 16. Antiderivative for sine is negative cosine. So I'm going to make that a plus. 16 cosine of t over 4. And then we're going to add plus c. And then that's, you know, all we can do. Didn't have anything to do with the table, but it is a problem we were still able to do if we kept our cool and we know how to do integration by parts, if we know our UDV formula. So that's going to be all for this video. Thanks for watching.